Let's take a look at a mixture problem, and we're going to use systems of linear equations to try to solve it. The idea behind a mixture problem is we're going to take two things and mix them together. When we move into systems of three equations, we'll look at mixing three things together, but let's start out with two. A bartender is trying to make an Arnold Palmer, sweet lemonade mixed with dark iced tea. Sweet lemonade has 45% dissolved sugar, and the dark iced tea has 25% dissolved sugar. How much of the sweet lemonade and the dark iced tea should be mixed together to give him a total of 8 liters with 30% dissolved sugar? Remember, when we're working with word problems, one time reading through is never enough. So take a moment and read through it again. If you need to pause the video. Read through it again and see if you can identify what we're being asked to find. Also identify what we are given. We're asked to find how much of the sweet lemonade and the dark iced tea. Since we're being asked to find those, let's let those be represented by our variables. So let's let x be the amount of lemonade and y be the amount of iced tea. The given information, we have sweet lemonade has 45% dissolved sugar. Dark iced tea has 25% dissolved sugar. And we want a total of 30% dissolved sugar. Notice if you try to add 45% and 25%, you're not going to get 30. Percentages can't just be added. We have to take those percentages and convert them into actual amounts instead of relative amounts. Percentages are relative amounts. The other piece of information that we're given is that we want a total of 8 liters of drink. So to visualize this, let's draw a picture. We have a vat of lemonade that we know has 45% dissolved sugar. And we also know that X is going to represent the amount of lemonade, the total amount of lemonade that's in that bucket. We're also given iced tea, so we have a bucket of iced tea. We know that we have an amount of iced tea that we're going to call Y, and that the iced tea has 25% dissolved sugar. Now we take these two amounts and we pour them into the bigger vat. This bigger vat is our Arnold Palmer, the iced tea and lemonade mixed together. And when we put the lemonade and the iced tea together, the total amount of lemonade plus the total amount of iced tea goes into that bucket. So X for lemonade, Y for iced tea goes together. The idea is pretty simple. If we had 1 liter of lemonade and 1 liter of iced tea and we mix them together, we have 2 liters of Arnold Palmer. 1 liter of lemonade and 2 liters of iced tea. 1 plus 2 would be 3 liters of Arnold Palmer. But we already know how much Arnold Palmer we want. We want 8 liters total. So we also know that this X plus Y is 8 liters. We are also given that this Arnold Palmer should have 30% sugar. Okay, so we have one equation right here from the lemonade plus the iced tea equals the Arnold Palmer. So that X plus Y equals 8 is one equation that we're going to use. The second equation comes from keeping track of the sugar. So let's write some information down. If we have X amount of lemonade and 45% of the lemonade is sugar, then we can multiply 45% times X, and that gives us the amount of sugar. So think about it this way. If I had 1 liter of lemonade, 45% would be sugar, so 0.45 liters would be sugar. That's a lot of sugar. Similarly, for the iced tea, we would take 25% of Y, and that would give us the amount of sugar in the iced tea. So if we had 1 liter of iced tea, 1/4 liter, 0.25, would be how much sugar is in that vat. Now we don't know what X and Y are. I'm just throwing in numbers to give us a tangible representation of the amount of sugar or the amount of the liquid. That's what we're trying to find. But this sugar gives us the second equation that we need in order to solve for the two variables that we're given. Remember, with two variables, we need two equations. When we have one variable, one equation is sufficient to solve. But once we put in another variable, we need another equation in order to get a solution. And even then, we're not always guaranteed a solution. So for however many variables we use, we need that many equations in order to possibly get a solution. This one does have a solution, which is great. We're going to keep track of the amount of sugar. So 0.45x plus 0.25y, total amounts of sugar. That's going to equal the 30% of sugar that's in the Arnold Palmer. Now we could put 0.3 times x plus y, but that's a little bit redundant. We already know that x plus y equals 8. We know that this here has 8 liters in it. Let's go ahead and use that information. So 30% of 8 liters will be the amount of sugar in the Arnold Palmer. And looking at this, that means that 2.4 liters out of that total 8 liters is going to be sugar. 0.3 times 8 is 2.4. Now we have our two equations. And I'll write them a little bit neater so that we have them together. But this first one, x plus y equals 8, keeps track of the amount of liquid. And the second one with the decimals keeps track of the amount of sugar. Let's write them down together. X plus y equals 8. 0.45x plus 0.25y equals 0.3 times 8, 2.4. And now that we have our system of equations, we can use either substitution or elimination to solve the system. Since my first equation has coefficients of 1 for x and y, I'm going to use substitution just for now, but you could use elimination. It's totally fine. The other thing that you could do also is multiply this entire second equation by 100 and get rid of those decimal numbers. But that's another option that you could do. It's not required or necessary that you do it. So let's take the first equation. I'll solve for y. And if you think about it, y equals 8 minus x. This makes sense because 8 is my total Arnold Palmer. So if I take out the lemonade, I should be left with iced tea. So I'll take this expression, 8 minus x, and I'm going to replace the y with it. So 0.45x plus 0.25, 8 minus x equals 2.4. I have one equation with one variable, and again, I'm taking that 8 minus x for y, and I'm substituting it into the other equation for y. And we'll multiply things out. 0.45x, distribute the 0.25, 0.25 times 8 will be 0.2. We've got some like terms on the left side, so we can use our calculator if we can't do that in our heads, and that's totally fine. 0.45 minus 0.25 is 0.2, so we have 0.2x plus 2 equals 2.4. And to solve for x, we would subtract 2 and then divide. X is 0.4 divided by 0.2, which should be 2, but I'm just going to check. It sure is. X is 2 liters. Then we take that x is 2 liters and we can use it into either of the two equations above to find y. Now that we've used both equations to find one variable, we can take that one variable value of 2, plug it back into either of the equations for x, and find y. Since the first equation is simpler, I'm going to plug it into the first equation. X plus y equals 8. 2 plus y equals 8. Subtract 2. Y is 6. So what do we need? We can write this out. We need 2 liters of lemonade and 6 liters of iced tea. And that would be our answer for the problem. But let's make sure that makes sense. So I'll go back up to my picture and the information up here. We'll do a quick check along the side. So we're going to check 2 liters for lemonade and 6 liters for iced tea. Total of 8 liters. 2 plus 6 does give me 8 liters. But let's see about that sugar, see if that makes sense. So 45% dissolved sugar for the lemonade plus 25% dissolved sugar for the iced tea. And we'll get 0.9 liters of sugar in the lemonade and 1.5 liters in the iced tea. And we add those together, we get 2.4. And also notice that 30% of 8 is 2.4, and they match. So the amount of sugar stays the same in the whole system, and the amount of liquid on the left side and the right side are equal. And that's really what we're showing. The amount of sugar on the left and the amount of sugar on the right is equivalent, and the amount of liquid on both sides is equivalent. And that's how we do a mixture problem. These seem overwhelming because there are a lot of numbers, but the key is to break it down into smaller pieces, keeping track of what you're being asked to find and what you're being given. There could be different setups of a mixture problem. Instead of not knowing what we're going to mix but knowing the final amount, maybe we have some amount of lemonade. I have 3 liters of lemonade. How much iced tea do I need to mix in order to end up with 30% sugar in an Arnold Palmer? So how much iced tea do I need? That's a different type of question, but it can be solved very similarly with the same setup. In these homogeneous mixtures, where we have dissolved sugar or dissolved chemicals, you'll see percentages in those types of problems. Another type of mixture problem is usually for heterogeneous mixtures like trail mix or candy mix. And instead of keeping track of amounts of particular items in there, you're looking at prices. So you may say that this candy is so much per pound and this other candy is so much per pound. How much do I need to mix it to create a mixture of this particular dollar amount per pound? So it's a different type of scenario, but again, set up very similarly in scope.